class, we are starting chapter 7. This is chemical reactions. We're looking at evidence of a chemical reaction. So your chapter 1 or chapter 17.1 discusses a school project with baking soda that reacts with acetic acid in a volcano. And what happens is that carbon dioxide is a product. So once these two compounds react, carbon dioxide is produced, which is a gas, which then forces the water and the sodium acetate out of this mountain that looks like lava. This is a sign of a chemical reaction. What you start with is not what you end up with. However, the atoms never change. Whatever the atoms that you have in the compounds, they don't change. They simply switch partners like a dance. If you're dancing with somebody, now you're dancing with somebody else. Same people are on the dance floor, they just change partners. So we're going to look at evidence of chemical reactions. So a chemical change is something that happens. It occurs when a substance is converted to one or more substances. So a chemical reaction has occurred. What you start out with is no longer what you end up with. You have something different on both sides. And most of the time, what we're going to discuss in this section is observable differences that indicate that a chemical reaction occurred. This could be bubbles, something bubbling, a change in color, production of a solid, which we call a precipitate, or heat that's being generated or observed, something like a cold pack or an ice pack. Those are chemical reactions occurring. Something that is not as visible, and some reactions can take a long time, some are instantaneous. Tarnishing of silver can happen over time. It's a slow process. And what happens is that silver, as you see, it's black there. It's no longer just silver. It's a silver oxide or silver sulfide. And it is slowly, in a sense, decomposing because it's no longer silver. It's losing the silver into another substance. And the silver itself is no longer there as what you know it to be. And will lose more and more of it as this tarnishing keeps happening, same as rust on a nail. So evidence of a chemical reaction. If we look at the atoms and molecules, if we could see these, we would see the atoms moving. We would see them changing partners. We would see these new molecules being formed. However, we can't see that. We would see the original molecules, the bonds breaking, and new bonds forming with new substances. But we can't see that. So what we have to do is look for evidence that a chemical reaction has occurred. And here, just to give an idea, reactants. Reactants are the starting materials. An arrow means that produce something that's yielded. A chemical reaction has occurred or may not have occurred if there's nothing on this side. But in general, for general here, we have a reaction. This would be products. So something new has been produced from the reactants. So what you start out with is no longer what you end up with. However, all the atoms are still there. They have just changed partners. So evidence of a chemical reaction can be a color change. If we were in person, you would do a titration lab. You would see a color, a very visible color change. Something would be, you would work with a clear solution and then it would turn pink. The formation of a solid in a previously clear, unclouded solution is a precipitate. Now the word solid in this terms does not mean something like a rock. We mean a visual change, even if it's lowly, a cloudiness, small, tiny particles, that is still considered a precipitate. Because what you started with does not look the same anymore and it looks like a white milkish, that is a precipitate, even if it's not a thick bunch of rocks and stuff. That's not what we mean here. Precipitate can be anything, small particles, milky color, to really a very clear, solid thickness that will sit at the bottom of a beaker. The formation of a gas when you add a substance. So when you have a chemical reaction, in some cases, you will see bubbling, and that is a formation, a gas has been produced. It's usually hydrogen or oxygen, and it's leaving the solution. So that's what you're seeing there. Emission of light. In some of these cases, light will be given off, and heat. Heat emission or absorption of heat. So again, those ice packs or hot packs, those are chemical reactions, and when you break them, the substances come together and they either absorb heat, which gives you the coldness, or they emit heat, which gives you warms your hands up. Okay, so let's break these down one by one. A precipitation reaction, this is a very visible one, but some of them are not this colorful, and most of them, in fact, are not. These are two different compounds that are coming together. One is, I think, potassium chromate and silver iodide. Don't quote me, but I'm sure, almost certain that's what these are. And when they react, they're very colorful. Well, one is colorful, one is yellow, and the other solution is actually clear. But when you add them together, you get this red precipitate that is formed, and it's a little thickness that you can see instantly. Not everything is that clear, but this is a good example of a precipitate. A gas evolution, so something when two compounds come together in a solution, one of the products will be a gas, and that's usually hydrogen or oxygen, and what you'll do is you'll see that gas leaving the solution. Now, the problem with gas is that there is one thing that is not a reaction, and you may instantly think of it, but it's not. Boiling water is not an actual chemical reaction, because what you start out with and what you end up with is still water. It's boiling away, but it's boiling away in gaseous form of water. So this is one example that a chemical reaction has not occurred. Nothing's being added to the water. It's not interacting with anything. It's simply boiling itself away. But it's boiling itself away as water still. It's just in steam. So this is not a chemical reaction. So when we talk about gases, we're talking about actual chemical reactions where compounds have been used, they interact, bonds are broken, new bonds are formed. Water is just by itself in this case. So again, evidence of a chemical reaction. If we could look at the molecular level, we would see these atoms, bonds breaking and new bonds forming. We can't always see that, so through chemical analysis, we can determine that a reaction has occurred, meaning what you started out with, that substance no longer exists. There is a new compound that has formed from the same atoms. Chemical reactions can occur without obvious signs, and that's where chemical analysis would have to come in. In this case, we're just looking at signs of a chemical reaction. Changes occur at the atomic molecular level, determine whether a reaction has taken place. Yes. Okay, so again, let's go through them. Changing color. Iron rusting is a perfect example of a change in color, because iron, if you see, these are brand new nails and these are rusty nails, but these rusty nails are no longer iron. They are iron 3 oxide, which means that they have combined with oxygen in the air, and they have formed a new compound. And given enough time, this will decompose. These rusty nails will just go away. They're slowly, in a sense, being eaten up slowly, just like the tarnishing of silver. So if you know anything about the Titanic is slowly rusting away. It is not what it was because it's in the presence of water, and anything that it can interact with the metals will. And James Cameron, who did the Titanic movie, has already said that he went down, I think, one last time 20 years later, and he can see a noticeable difference in what it looked like when they went down there originally to what it's gone down to now. So eventually, anything that can be rusted away on the Titanic will be rusted away as time goes on. Formation of a gas again. Bubble gas, when calcium carbonate reacts with an acid. Hydrogen gas is carbon dioxide is usually a product that is being produced when those two compounds, an acid and calcium carbonate, react together. Formation of a solid. Here's another one. A yellow solid forms when potassium iodide is added to lead nitrate. You can see there were two, you can't tell now, but these are two clear substances. And yet when added together, you see this yellow solid that's formed. And gas, methane gas burns in the air with a hot flame. Heat or a flame is produced. Warmth, a heat or a flame, and you can usually tell with heat being given off or heat being absorbed. So what changes involve in a chemical reaction? First thing you should always ask yourself, when you're looking at a substance, when this sentence is telling you, do you end up with the same thing that you started out with? And if you do, it's not a chemical reaction. It's not a chemical change. It may be a physical change, so you guys should definitely know the difference between physical and chemical changes. But every change is not necessarily a chemical reaction, is what I'm trying to say. So ask yourself, do you end up with the same thing on both sides? Ice melting upon warming, an electric current passing through water, resulting in the formation of hydrogen and oxygen gas that appears as bubbles rising in the water. Iron rusting, bubbles forming when a soda can is open. These are all on the same page, so I'm just going to go through them. Ice melting upon warming. Do I end up with the same thing? Yes, I do. So this is a physical change. It's not a chemical change. Same as boiling water. I still have water. I do not have anything else. And there is no other substance interacting with this substance to cause a chemical reaction. An electrical current passing through water, resulting in the formation of hydrogen and gas. This is decomposing water. Water is no longer on the product side, we have a hydrogen gas and oxygen gas. So water is what we start out with. The electrical current is forcing the water to break bonds and resulting in hydrogen and oxygen gas. So you do not have the same product on both sides. This is a chemical reaction. Iron rusting. I just went over this. This is a sign of a chemical reaction, because if you only had strictly iron, then you wouldn't have another substance. But we don't have that. We have iron combining with oxygen, and it is now a whole new substance that is iron oxide. So this is what the rusting is. So this is a chemical change. Bubbles forming when a soda can is open. So the first thing you need to know, we all know that soda gets flat when it loses the CO2, but you need to ask yourself, and you may not know this, but was the CO2 packaged in the can as it was being put in there, or was this a reaction that occurred in the can? And this is not a chemical change, because the carbon dioxide is used to put into with the soda before it's actually canned up. So, or sealed, is what I should say. So the carbon dioxide, we'll cover this in gases. The carbon dioxide is in the can, and once you open it, the CO2 leaves that. But it is, so it's not necessarily, it's not a chemical reaction. It's just in the can. So that is not a chemical reaction.